Aloha again, students. I'm going to be talking about Chapter 5, Cost, Volume, Profit Analysis. A more common term to use than cost, volume, profit, or CVP analysis is break-even analysis. The basic concept of break-even analysis is what is the point in which what we sell equals our cost, so our profit is exactly zero. Why do we want to know at what point our profit is exactly zero? Well, we know that we have to sell more than that in order to make a profit. So it's important for us to know what is that point where we break even. Before we get into the details of cost, volume, or break-even analysis, let's define a couple of terms. We've seen those before. Fixed costs. Fixed costs are costs that do not change over a range of volume. So the costs remain the same regardless of the volume. And that's illustrated here, if you were to graph it out, as a straight horizontal line. So if cost is the axis here, the vertical axis is cost, the horizontal axis is units, number of units. So regardless of the number of units, the cost remains the same. That's a fixed cost. A variable cost, on the other hand, is a cost that varies directly proportionate to changes in units. So if you double the number of units, you're doubling the cost of something. So that can be illustrated here with a 45-degree angle line starting from the 0, 0 axis, going straight up at a 45-degree angle. So again, the more the units, the higher the cost. So in our discussion last week, we saw that for a spam musubi manufacturer, for example, a fixed cost might be the cost of the rice cooker. So regardless of how many spam musubis we make, the cost of that rice cooker is still just one rice cooker, so it doesn't change at all. On the other hand, the rice for making spam musubi, the more spam musubis we make, the more rice we need. If we make twice as many spam musubis, we need twice as much rice. So that's a variable cost. A mixed cost, on the other hand, is a cost that has elements of both fixed and variable characteristics. So notice that in this third graph here, if you have zero volume or zero units, there still is a cost that is incurred. And that's, by the way, the cost of the fixed cost. So in our spam musubi example, even if we make zero spam musubis, the cost of that rice cooker is still there. Okay? So it doesn't start at zero cost. There is already a cost there, the fixed cost portion. And then as we produce more units, the cost goes up. Notice it's not a 45-degree angle, and it does not start at 0, 0 like a variable cost does. The line starts at the fixed cost point, okay? And that's a mixed cost. Most costs have the characteristic of mixed costs. So almost anything you can think of has elements of both fixed and mixed costs. So we have to take both into consideration when we're doing our break-even analysis. Another type of cost is called a step cost. Step costs are fixed for a certain level of volume, but then once it reaches a certain point, then it jumps up to another level and it stays the same, and then it jumps up again. It's called step cost because it looks like a step, but An example would be our spam musubi example. We only need one rice cooker, okay, to make a certain volume of spam musubi. But once we reach a certain point, we would need a second rice cooker. So the cost jumps up, and then we use that second rice cooker until we reach a certain volume. Then we might have to buy another one. So the cost jumps up and then stays the same. Okay, that's a step cost. In doing break-even analysis, we assume a specific range. So we kind of assume that we're going to be doing break-even analysis at a certain range, so we don't really take all the different steps in a step cost chart into consideration. We're mainly going to be looking at mixed costs when we do break-even analysis. Okay. Yeah. Okay. So in real life, obviously, costs don't go directly, variable costs are not a straight line at a 45-degree angle. It may look something like the linear line, so it kind of like curves instead of being a straight line. But we have to assume when we're doing our calculations that the line is relatively straight. Otherwise, our analysis is not going to work. Okay. Okay, so one more. No, we'll get to that later. Okay, so analyzing costs. So here's an example of various costs, okay, within a range. These might be costs for each month, okay, costs at various volume levels. In this case, it's a fleet of delivery trucks. So the company's looking at, for the miles driven, these were the costs. So at 30,000 miles driven, the cost was $38,000. At 40,000 miles driven, the cost was 42. And maybe the next month it was 60,000 miles driven, so the cost was 45, etc. Okay, so this is called a scatter diagram or a scatter graph. It basically plots all of the actual points of the cost relative to actual volumes. So again, this might be points for particular months, might be even per day kind of a thing. Okay, so our objective is to try to figure out a line that goes through all of the points. Okay, a straight line that goes through all of the points. Obviously, you can't really draw a straight line through all these points because they're like scattered all over. So we draw the line that fits best, the straight line that fits best within all of these points. The reason we do that is so that we can predict or analyze what costs would be. So for example, if this were the line that we drew here, we would know at 100,000 miles, the cost would be, and you draw straight across, about $65,000 or so. Okay, so again, we're doing this in order to predict what costs would be at various volumes. Okay, and that's the reason we're trying to draw a straight line. There's two ways of estimating a straight line through all the points in a scatter graph. The first is called the high-low method. That's a very simple method. Well, before we get to that, sorry. Okay, so what we're doing by drawing a straight line through all the points is We now know that where the line meets the zero volume, so approximately 25,000 here, we know that that is the fixed cost. Okay, because again, at zero volume, there's a cost there. That must be the fixed cost. So we know 25,000 is the fixed cost. Okay. So we also know that, excuse me, at 80,000 miles, we drew a line straight up to hit our estimated straight line, and then we go across, we see that that is about $57,000. What we're trying to do here is compute the variable cost portion of this mixed cost. So we do that by taking the $57,000 cost at the 80,000 miles, the $25,000 fixed cost at 0 miles. If we do the math, we see that works out to be 40 cents a mile. So again, we're doing this math, and we'll see that again later. Excuse the dogs barking. We'll see this later. And again, we're trying to figure out here what is the variable cost per mile. Okay, so we know the fixed cost per mile is where the line that we estimated intersects with the zero volume. So 25,000 here. And the variable cost, we need to find another point so that we know what the cost and the volume is at that point, because we need that in our equation here. And again, we do that to figure out the variable cost per unit. Okay, so the high-low method, one of the methods in estimating that line, what we do is we take the highest point in our scattergram or scatter graph, which is the 60 here. That's the cost. And the volume is about 80,000 miles. Okay, so 80,000 straight up to 60. It's a little bit kapakahi a little bit, but, and then you take the lowest point volume. So the highest was 60. The lowest is the 38. We look at the respective dollar amounts for the highest point, which is the $60,000, I guess, and the 30,000 miles or so, okay, here. And again, we use that formula. The highest dollar amount minus the lowest dollar amount divided by the highest volume minus the lowest volume. And again, that's the highest point and the lowest point. We get the difference of the dollar amount in the numerator, 22,000. We get the difference in the volume in the denominator, in this case 50,000. We do the math and we get 44 cents a mile. So now we know that the variable cost is going to be 44 cents a mile. Okay? So now we have to compute the fixed portion. So to do that, we take either the highest point or the lowest point, either one. In this case, they're taking the highest point, which was 80,000 miles. At that level, the cost was $60,000. Then we subtract the variable portion of the mixed cost. The variable portion we calculated up here was 44 cents a mile. We have 80,000 miles, so 80,000 times that 44 cents gives us 35,200 is the variable cost portion. So the difference between the total cost and the variable cost is the fixed cost. So 24,800 is the fixed cost. Okay, so now we know that And this, hold on, this, yeah, doesn't give you the formula, but now we know that for any point on this line, the fixed cost is 24,800 and the variable cost is 44 cents per mile. Yeah. So for example, if we were to try to figure out what the cost would be if we drove 100,000 miles, it would be 24,800 fixed costs. Remember, that doesn't change, that stays the same, plus 44 cents a mile times the 100,000 miles, the point at which we're trying to figure out the cost. So that would be $44,000. So add the $44,000 of variable cost to the fixed cost of 24,800, and that'll give you the total cost. So 68,800 would be the total cost of driving 100,000 miles. Okay, so again, we do this process in order to figure out at any volume what the cost would be. Okay, again, the high-low method is a very easy and quick and dirty method. Again, we take just the high point and the low point and draw a line through those two. Okay, and again, that ignores all the other points. So as we saw in our example, the points didn't exactly match up. That line that you drew through the 60 and the 38 was off from this first estimated line that we had. Okay, but again, it's a quick method. The other method and how they got this line here is using something called multiple regression. Basically, that is a statistical calculation, and it's beyond the scope of this course, but you can use Excel to do multiple regression analyses. Multiple regression analyses takes into account every single point in the scattergram and then tries to calculate the best line through all of the points. So it's a much more accurate measure, but it's a little bit more complicated than the high-low method. And again, the high-low method is just a quick way to estimate that line. Yeah, as we saw earlier, that quick and dirty high-low method resulted in a line that was higher up than the multiple regression would have come up with, so it was slightly off. Okay, but again, it's just an estimate, so we will use that. Okay, so again, we're not going to be doing the multiple regression in this course. If anybody's really interested, just ask me and I could show you how to do that using Excel or some other kind of computer program to do that. But again, the multiple regression analyses takes into account every single point. So if there's 1,000 different points on this line, that will take into account, you have to input all 1,000 of those points in order to get an estimate of the line, the best line through all the points. The high-low method, again, just takes the highest point, the lowest point, and ignores all the others. So it's more subject to variability and error, but again, it's a nice quick way of coming up with an estimate. Okay, and again, we'll go through the high-low method in class just to practice that. Okay, so looking at this chart, we see that, I wish they would have made this in color, but the line that starts here at $40,000 at zero volume, that must be the fixed cost there. Okay, that line there is, again, the cost line, okay, that we just came up with for using this high-low method. Okay, the line that starts at 0 and goes up, that's the sales line. Makes sense. If you don't sell any, there's $0 of sales, and the more you sell, the higher the price. So the point at which your sales equal your costs, so where the two lines intersect right here, that's your break-even point. So it looks like $100,000 of sales will give you zero profit. That's break-even point. And 5,000 miles driven results in the sales being exactly equal to the cost. So there's no profit. Okay. So in this chart, the area grayed out here is the profit or net income area. Down here is your net loss. So if anything below the break-even point, you have a loss. Anything above the break-even point, you have profit or net income. So you can use a chart like this to try to figure out what we just said, but that's very imprecise. I don't like charts because it depends on how well you draw them. So let's use formulas instead to figure out what the break-even point is. Before we do that, let's look at a term called contribution margin. Contribution margin is basically the revenues that exceed variable costs. So sales revenue minus your variable cost is your contribution margin. Okay, basically that's how much money are you making on the products that you're selling, not taking into consideration your fixed cost. Okay, so another way of thinking this is how much profit is contributed toward covering your fixed cost. That's what contribution margin is. Okay, so so this profit equation down at the bottom of page 141, net income equals your revenues minus your total variable cost minus your total fixed cost. Okay, this is something you learned back in MBA610. It's basically what the income statement looks like. Basically, this is the variable costing income statement that you saw at the end of chapter 3. Okay. So net income equals revenues minus total variable cost minus fixed cost. Okay. So plugging in the information here for the example that was given to us, they had $120,000 of revenue. Their variable cost was $72,000. Fixed cost was $40,000. So their net income or profit was $8,000. Okay. So let's now try to find what the break-even point is. Okay. And I think we're going to be using the same example. Okay, so excuse me, there's two break-even points that we want to try to compute. We want to see what the break-even point is in units. So we have to sell this many units in order to break even. And we're going to find the break-even point in sales dollars. So how many dollars of sales do we need in order to break even? Okay. So for break even in units, the calculation is your fixed cost divided by your contribution margin per unit. Okay, so contribution margin per unit is your selling price per unit. How much do you sell each unit for? So $20 in this case, minus the variable cost per unit. This they tell you is $12 per unit. So the contribution margin per unit is $8 per unit. Okay, so they're making $8 on every unit they sell. That goes toward covering your fixed costs. So $40,000 divided by $8 per unit, you see that the break-even point in units is 5,000 units. So they have to sell 5,000 units in order to break even. Okay, if they sell more than 5,000, they'll have a profit. They sell less than 5,000, they'll have a loss. Okay, finding the break-even point in dollars is similar to the break-even in units, but instead of using contribution margin per unit in the denominator like we did to find the break-even in units, we're going to divide by the contribution margin ratio. And the contribution margin ratio, see here, is calculated by dividing the contribution margin per unit, that same $8 that we saw earlier in the break-even unit calculation. And we divide that contribution margin per unit by the selling price per unit. So in our case, the 20 bucks. So it's the $8 contribution margin per unit divided by the selling price of $20 gives us 40%. That's the contribution margin ratio. And that's what the 0.40 represents, 40%. Okay. Excuse me. Another way to get that 40% ratio is, rather than doing it per unit, we could do it in total. So total contribution margin in total is 48,000. That's the excuse me, $120,000. I'm trying to find where they tell you that. Let's see. Oh, the $5,000 times the $20 selling price gives us the 120,000. Hold on, let me just check this real quick. Oh no, they tell us right here. But anyway, total contribution margin divided by total revenues gives us the same thing. I would do it using per unit calculations here, okay, because that's a lot easier than trying to do the math to get to the totals, and you get to the same thing anyway, okay? So use the per unit calculations to get the contribution margin ratio. So now what we do is we take our fixed costs, divide by the contribution margin ratio, at 40%. So $40,000 of fixed costs divided by our 40%. And in an equation, 40% is 0.40, gives us $100,000. Okay, so that tells us what the sales in dollars need to be in order to break even. Okay, remember the break even in units was how many units we need to sell to break even. Break even in dollars is what's the sales volume in dollars in order to break even. And actually, an easier way to figure out the break even in dollars is take your break even in units, 5,000, and simply multiply it by what you're selling it for, $20 a unit. 5,000 times $20 a unit gives $100,000. That's exactly the same thing that you got going through all the calculations. So in my way of thinking, an easier way to get the break-even point in dollars, instead of going through all of this, is calculate the break-even in units first, and then just multiply that by the selling price per unit. Okay, that's a whole lot easier than going through all the steps that they tell you here to calculate break-even in dollars. Okay, although you should probably know this, but for purposes of the exam, you come up with the same dollar amount. So I think it's just as easy. It's easier to do the break-even in units times the selling price per unit. 5,000 times the $20 gives us the same 100,000. You can go ahead and do that. You don't have to go through all the calculations. Although you might want to, just to double check yourself, but you'll come up with the same answer. Okay, so as a proof here, we said $100,000 was the break-even dollar amount minus your variable cost. Variable costs We're $12 per unit, they tell you here. And I wish there was a way to highlight this, but I might have to figure that out later. But here, $12 a unit's a variable cost. 5,000 is the break-even units times the $12. That's 60,000. Gives us contribution margin of 40,000 minus our fixed cost of 40,000. Gives us net income of 0. So that's proving that $100,000 is the break-even point. Okay. Okay, so we'll practice calculating break-even points in units and in dollars when we do the homework. Okay, so go ahead and make an attempt to do that homework. Okay, calculating break-even for a multi-product company. Let's see. You know what? Don't worry about that other than the terminology product mix. Yeah, don't worry about the calculation. Product mix basically means what proportion of the various products that a company sells. Okay. For example, it's 50% product A, 30% product B, 20% product C. That's product mix. And it's beyond the scope of this course, but accountants try to figure out what's the best percentage of each of the products to sell based on the profitability of each individual product. This particular calculation here is doing it in total to get a rough idea. But again, accountants have very precise means of calculating that kind of a thing. And again, that's beyond the scope of this course, so we won't really get into that. Okay. Okay, the term margin of safety. Margin of safety basically indicates what you're currently selling versus what the break-even point is. So that's the cushion that a company has. So for example, this company, the break-even in sales was 100,000. They're currently selling 120,000. So they have 20,000 more sales than the break-even point. So they have that cushion. So in other words, if their sales went down by $20,000, they could still break even. Okay. Another way to look at that is to use the same information and come up with a ratio or margin of safety rate, margin of safety ratio. That is taking your current sales minus your break-even sales. Okay, that's the $20,000 is the numerator because we calculated it up here. You divide that by your sales dollar, current sales dollar, the 120, and you'll come up with 16.67%. So that's a little bit more useful. That indicates that a company sales could drop by 16.67% and they would still break even. So it's more useful to look at this margin of safety as a percentage, yeah, because that takes into consideration the scope or scale of a company, the relative size. So yeah, that's pretty good. This company can lose 16.67% of its sales and still break even. So that's a pretty good cushion. Obviously, the higher this percentage, the better. So margin of safety ratio, the higher, the better. In other words, they have a bigger cushion in case they lose sales. Okay, so that's what margin of safety is basically, is how much cushion does a company have based on current sales before they start to lose money. Okay. The next part of this is an illustration again of calculating break-even points. So again, yeah, we'll talk about those when we look at the homework assignments. Let's see, objective 8 here is just indicating that Excel spreadsheets are an excellent tool to use in calculating break-even points. And I didn't assign you anything to help you do that, but again, accountants use pretty sophisticated spreadsheets sometimes in order to calculate this break even rather than using calculating formulas like we did earlier. They use spreadsheets, and it's easier that way. That's basically the information on chapter 5. So go through the homework that we assigned, and we'll go through those in class on Tuesday. Okay. Oh, by the way, for the Zoom quiz for this week, I'm going to ask you what my favorite food is. The answer is, sorry, excuse the dogs. Okay, my favorite food is sushi. Okay, so remember that for the quiz. Okay, that's it for chapter 5. So, aloha.